Okay, I'll get started then. My name's Gina Canarozzi. I'm at the Chemistry, Biology, Pharmacy Information Center at ETH Zurich, and this is coffee lecture number 54 on PyMol. So what is PyMol? PyMol is a software package for visualization of biomolecules. So you can see in these pictures here, you have proteins, you have DNA, and you have a zoom in of an active site. If you look at the first picture, you can see that this is a protein. It's visualized as a purple ribbon, so we can customize how we visualize and the colors. You can see the ligand in there is sticks and it's yellow. And then you can see the membrane here is visualized as a surface. And you have cholesterol molecules, which are green, and they are visualized as a surface. But if you look inside, you can also see that there's sticks inside there. So this illustrates a lot of the beauty of PyMol, is that you can change the visualization. Do I want a surface? Do I want sticks? Do I want a ribbon? You can change the colors, and you can add labels. One thing that makes this possible is selection. So you have to be able to select certain parts of the molecule. And once you've selected certain parts of the molecule, which you can do by name or by structure or by type, then you can color it or label it or make it how you want. In this picture, you see DNA. The DNA is visualized as red and orange ribbons, and you see it's wrapped around histones, and the histones are here a blue surface. And here we've zoomed in on the active site. And the thing that this picture adds is that you have bonds drawn. The dark purple is the protein, and you see a side chain here, which is interacting with the ligand. So you can measure the distance here. I could display this as a number, how many angstroms that is, or here they've chosen just to draw it as a dashed line. So these are some of the things that are possible. As I was saying before, the PyMol can read in anything with 3D coordinates. So what you get from PDB is a file that has the location of all the atoms, the XYZ coordinates. Here you have the output of a molecular dynamics simulation of an aquaporin. Here's the aquaporin, here's the lipid bilayer, and they have water in there, and it's all displayed separately. You have functions to display RNA, and you have functions to display DNA. So that all seems to be like the special functions are for drawing biomolecules. You can download PyMol from Schrödinger. Schrödinger is doing the maintenance and distribution now. It used to be free software. It's not anymore. But you can download it here for Windows, Mac, and Linux. And the Py in PyMol is Python. It's written in Python. It's its own interpreted language. So when I write code in the PyMol language, but it also runs Python code. And this makes it nice if you want to customize a script, or if you want to turn a molecule 5 degrees and you want to compute something in Python, then if it's not PyMol code, it'll be interpreted as Python. At ETH Zurich, we can get a license for PyMol at the IT shop. So you can see for staff, it's 1 year renewable. For students, it's unlimited. If you're not at ETH Zurich, then they have an academic license, which has some limitations on its functions, or you have to pay for a license. The PyMol wiki is the best place to get information about PyMol. They have tutorials, they have all the documentations, they have the latest commands. And the nice thing about PyMol is it has a big user-supported community. The community is always writing scripts that they share. They have plugins. So for example, PyMol itself won't do molecular dynamic simulations, but you can interface to Gromos through a user donated plugin. And the other one I use a lot is this APBS electrostatics that lets you visualize the electrostatic charges on the surface of the molecule. Okay, so as I mentioned, the input files are 3D coordinates. The most common place that we get input files is from the PDB, the protein data bank. Here is the data bank that holds all the experimental structures. So around now, there's 216,000, this was this morning, structures in the PDB, but it also has a lot of computed structures, and the AlphaFold protein structure prediction program outputs its predictions in PDB format, so you can read all of those in also. The output files are either PNG images or movies. You can make both in PyMol. So since the advertisement was about the beautiful pictures you can make, you should be aware that in PyMol you can use the draw, which is simple drawing, or you can do ray tracing, and you get a lot nice pictures. If you do ray tracing, it takes a little bit more time. So what I normally do is, if I'm just looking to see how things look, I use draw. But if you do ray tracing, you can see here you have nice shadows. This is a higher resolution output and better quality. So when you do your publication quality photos, you should use ray tracing. Okay, so now I would like to do a demonstration of PyMol. However, my mouse isn't working, so we'll see if this works. So this is the PyMol interpreter. You can see over here, I have a command line. I can go directly to the PDB and collect something from there. I have an object viewer over here, and I wanted to show first the demonstrations. They have some demos here, and you can see, if you look at the representation, the different representations you can have in PyMol. So you can have lines, you can have sticks, spheres. Here's the surface again, and the mesh and the dots are see-through. So if you wanted to display something as sticks and a mesh, then you can see the actual chemical structure, but you can also see the space it takes up. So everything here is completely customizable. The other thing that I use quite a lot are the cartoon ribbons. If you look at proteins displayed in journals, it's quite often a ribbon structure. And this one is called publication. And in the publication view of the protein structure, you can see it's colored on the outside and gray on the inside, and it has this little lip here. So there's a little more detail than the normal ribbon view. Okay, so let me end the demonstration and show you, like from PyMol, you can do everything from either the menus up here. There's some commonly used commands up here, or I can do it from the command line. So if I type fetch, and I'm going to do 1-PFK, which is a phosphofructokinase PFK, then I can fetch, F-E-T-C-H, I can't see it, 1-PFK, thank you very much. Then I have the molecule here. And you can see when I add this molecule, I get over here an object. And so now I've created an object that's 1-PFK, and I have these menus where I can perform an action. The actions has some preset visualizations. So here's pretty, I can do that. I can zoom in on it. I have a number of things I can do. The other menus here are show. So I can show it also as a mesh, and then I see the ribbon and the mesh. And what's nice about this is any part of the molecule you can select, you can display it however you like. This is the hide. I don't want to see the mesh, so I'm going to hide the mesh. Label is where you do all the labeling. I'm not going to look at that, but you have color here, so I'm going to color it cyan because I think cyan is an okay color. One thing I like to do if I'm going to print it is set the background color to white. So that's BG_color white. And I think the resolution is better here. Okay, so what I want to do normally when I visualize is to select different things. If I go down here and hit this S, I can see the sequence viewer, and now I have the entire sequence here. So that works. And I can see that was the protein sequence. In here, I have the ligands. So I want to view these ligands up in this pocket here, and I know which ones they are because I've used this molecule before. And then I've now selected the ligands. And you can see when I do a selection here, then I get the selection up here, and I can go action, rename the selection, and then I can rename it to ligands. And now I can deal with the ligands separately from the protein in any way I want. And what I want to do is color them so that they stand out. So I'm going to do magenta. And now my ligands are magenta. By doing selections and coloring them, I can make the visualization any way I want. One thing that's nice to do is define things in terms of a distance. So if I want to define the active pocket around this ligand, I can do that by, let's see if I can do this without a syntax error. Select. So there's a big selection syntax. I'm going to call it active because it's the active site pocket. And then I'm going to do it by residue because I don't want to select just atoms. I want to select residues in the protein. I'm trying to define the residues in the protein that may be interacting with those ligands. And I want all within 5 angstroms of ligands. And I made that ligands. Is that good? And ligands is defined here. Remember, I use the name ligands, so ligands is defined. And if I do that, now you can see that little pink dot means that it selected those atoms. Now I have that called active. I can call it, I can color it yellow. And maybe for this one, I want to show it as a surface. And then I can actually see how the, do you see the ligands? The ligands are changed color again too, because, all right, we'll make the ligands magenta again. And now I can look and see how the ligands lie exactly in that pocket. So although this picture isn't beautiful, the color scheme is kind of, could be improved. You can see how by selecting things, defining objects, and then changing the color and the labels and the form, I can get the visualization that I want. One last thing is that I can store these scenes as scene 002, comma store. I can store that picture. And now you see down here at the lower left, there's a 002. So if I move this, I can go there and click on that 002, and it'll go back to where I was. And you can see it makes a turning transition. So if I want to make a movie in PyMol, I define scenes, and then I can set up a movie that moves from scene to scene, and PyMol will handle the transition between the scenes. So we have 10 minutes. 10 minutes is up, but I'm happy to take any questions from people in the room or on the web.